Week 5, we're going to start talking about nutrient requirements and what that means and how we can utilize those as we start building into ration formulation. This is the first part of, I think, about a 4-part series on nutrient requirements for animals. We're going to talk about just a general introduction to what they are and why they're important and how they're determined in this small video. If we're going to feed animals successfully, we have to have an understanding of several things. One is the digestion and absorption process. How do they utilize the food that you give them? We covered that during the first week of this semester when we evaluated the digestive systems of the variety of animals we're going to be working with. We then spent the next couple of weeks looking through the different types of feeds we have to work with and understand which feeds can be used for different species. Now we're going to be able to start utilizing that information once we understand the quantity of nutrients needed by the animal. We are now at the point that we can start balancing rations once we understand what nutrients the animals require. Let's define a requirement. When we talk about a requirement from a nutrient standpoint, it is that quantity or the amount of a nutrient that the average animal requires for a typical function. It is considered an average value. For some animals, it may not work, but it's going to get us close to what that animal really needs. But we do need to understand that what's reported and publicized in the tables that we're going to be using is that these requirements listed are for the average animal. Also, it's usually a minimum amount required to prevent a deficiency, and so, or to allow performance at XYZ level, but it's usually a minimum. So we work a lot with minimums and realize that we can probably go over it. We just need to understand the implications of having higher than the required amount, and what does that really mean. When we talk about nutrient requirements, there's the minimum requirements that are reported in all the tables, but what we're really wanting to do as nutritionists is we want to optimize our requirements. We want to optimize production. We want to get the most production out of our animals for the dollars that we're putting into them. And we want to make sure they're healthy, they have a good life well-being, and they're able to produce at the levels that we want them to. And so understanding that what's required for optimal production may not be the same as what's required for minimal production. Let's take a look. If we were to graph out production from the standpoint of, let's take a look at whatever amount of a nutrient an animal needs. And this is going to be a generic graph. We're going to go from low levels of the nutrient to high levels of the nutrient. We're also going to go from low levels of animal performance to higher levels of animal performance. So we could think about things like, say, a lactating dairy cow. Small amounts of a nutrient, say protein, energy, calcium, phosphorus, whatever we want to evaluate, and how does that impact her animal performance? So when we take a look at animal performance, what we're going to see is that depending on the amount of nutrient at either the really extreme low or the really extreme high, it's not going to have a major impact on animal performance. But somewhere in the middle is a threshold that's going to optimize or maximize animal performance for that amount of a nutrient that we're going to put in. So if we take a look at the lower and upper ends of the spectrum, if we have a situation, actually let me just pull that up for just a sec. Sorry. If we look at the lower end of the spectrum where we have a small amount of nutrient that is going to, a small amount of nutrient that is negatively impacting animal performance. And what that is resulting in is what we call a nutrient deficiency, meaning we have this small amount of nutrient down in here, a lower level, and we're seeing low animal performance. That means we probably don't have enough of that nutrient to optimize the performance level that we're after. Now on the flip side, we can see high levels of a nutrient actually suppress animal performance as well. And that's a case where we could actually potentially have toxic levels of a nutrient that could actually hurt the animal. And some examples include the minerals like selenium can be at a toxic level. Sometimes the fat-soluble vitamins can be stored in the body and reach a toxic level that they would actually impair animal performance. Then we get into a couple of regions on either side of that would be considered marginal in terms of meeting the amount of the nutrient needed to maximize performance. And we have our minimum requirement is actually at the bottom end of that marginal range for the deficiency. That's where most of our requirements are. And so you can see that we would likely want to still increase our requirements slightly above those minimums to be able to achieve what we call optimal performance. Oops, too fast. To get to that optimal range. And so that's what we are going to spend the next series is visiting, is about how did the different nutrient requirements change throughout an animal's life cycle for maintenance, for growth, for reproduction. The trend in nutrition is towards formulating for optimum production, which is logical and makes sense. But it is difficult because we can have animal-to-animal variation and understanding what is optimal without going to too much, because as soon as we start crossing over into excess nutrients, we're paying for things that we don't need. So there is a fine line. And that optimum level could be different depending on the production requirement or production criteria. An example of this is copper. There's a certain amount of copper that may be needed for optimal growth in, you name the animal, say a pig. However, there may be a different amount that's actually needed for immune function. And so how do you know which one is the best to feed for? And so those are some of the things that research has been focusing on in terms of really understanding what these nutrient requirements are in our livestock. And so that we can be be the most accurate formulators of diets that we can be. And this is why, after all of this, we still generally balance for the minimum requirements. However, there's cases like in feedlot steers, the minimum requirement for protein is like 12%. However, almost every feedlot bumps it up to about 14.5% protein. Why? Because that's actually getting it up closer to the optimum level, not just the minimum. There's a lot of different factors that influence nutrient requirements in animals, and it really can have an impact on how you formulate your diets. First is species. Pigs have different requirements from cows, which have different requirements from dogs. Very definitely an impact on what requirements are needed. The breed, a good example is, say, beef cattle. We have our Bos Taurus breeds like Angus, Hereford, Shorthorn, and we have our Bos Indicus breeds, the Brahman, Brangus, and those, and they actually have different nutrient requirements, so breed can play a major role. Gender in some animals, male versus female. In growing pigs, gilts are actually leaner and more muscular, and they actually have higher protein and energy requirements than their castrated male counterparts of the same age. So gender can play a role in some species. Age, their basal metabolism rate, and that's based upon body weight, and so there's a relationship there that we'll talk about. Their physiological production status, are they lactating? Are they not lactating? Are they growing? Are they getting ready to breed? All of those things can influence how much of the different nutrients these animals are going to need. Overall health status. Animals that are sick generally eat less and actually require increased concentrations of nutrients in their bodies to make sure that they're able to consume the right amount. And also our environment, the outside environment. Is there heat stress? Is there cold stress? These can drastically affect our livestock and our companion animals in terms of what requirements, what nutrients they require. When we talk about estimating requirements, there's been years and years and years of research, and we have major publications that talk about the nutrient requirements for different species of animals in different stages of productions. The main ones, the National Research Council, the NRC, and I have most of the publications. I've got a few more of the more current ones that I need to order, but these are literally groups of scientists that go through the literature for the past 5 to 7 years and update what the minimum requirements are for various animals at different stages of production. And it's a subdivision of the National Academy of Sciences. And what happens is the NRC actually appoints a subcommittee, say the beef cattle subcommittee or the dairy subcommittee. They have a lab animal subcommittee, a fish subcommittee. So those subcommittees work to develop and compile the data on nutrient requirements. The publication that's produced for each species, we're going to be using the textbook that has a lot of nutrient requirement tables in it. Those requirement tables, it'll say which publication it's coming from for those species. And so from the NRC, we have two primary ways that we can estimate our nutrient requirements. One is looking at the tables and getting a ballpark idea, and we'll be doing some of that in this class. The other way is through equations. A lot of the NRC publications are utilizing modeling, computer modeling, mathematical modeling, and developing equations that can predict animal performance. For example, if you have X amount of energy, X amount of protein, this is what we predict the animal is going to be gaining. A few of the spreadsheets we're going to be using this semester will utilize those equations and predict animal performance. We also express animal requirements in two different ways. The first is what I call the quantity or the daily intake. You'll also hear me refer to this one as, get a pin out here, as absolute. Okay, absolute meaning how much are they actually eating per day. That's the quantity method. That's one way of expressing the requirements, is that cow requires 5 pounds of this per day, or 15 pounds of TDN, 2 pounds of protein, whatever the situation is. The second method is through proportion of the diets, or concentrations. This is where we talk about percentages, parts per million, which is the same as milligrams per kilogram, but this is some sort of a concentration of the diet. And so we will be working through examples that deal with both quantity and proportions. And so we will work through the two different types, two different methods of expressing nutrient requirements.